if I'm going to graph this piecewise, I want to break it down and focus first on the intervals. That interval, and that interval. And I'm going to plug values in on each interval. So first thing I'm going to do is plug values in at each break point. So that's a break point at -2. I'm going to be plugging in -1, 1, and 2. I'm going to plug those numbers into the functions and create graphs with points. So watch this. I'm going to put the value -2 into the function next to it. Watch what happens. If I put -2 in, what you're going to get down here is you're going to get f of -2, and I'm plugging into the top function. So what I'm going to do is this, and what does that give me? That's a -2, sorry. -2 in there. Do you see that's 1? So I'm going to go over here, go -2, and go up 1. There's a point of the graph. Now, real quick, do you understand when I have this sign, do you not understand that means open circle? So at -2, I'm going to have an open circle. So let me fix that and make an open circle right there. All right. So I got that point. Next, I'm going to now try another value in this interval. You choose. For this interval, I got -2. I got the edge. I need to choose another value in the interval, preferably one that fits right here. So when you want to put in -3, -4, -5, we choose. It does not matter. Okay, -4. So let's plug in -4 and see what happens. I got to plug it into this interval. Got it? Because it's less than -2. So I'm going to put -4 in. So f of -4 is going to be 5 plus 2 times -4, which is, looks like -3. Does that look right? So at -4, we're going to go down -3, and then I connect the dots. Can't you make a line with 2 dots? Got that? Instead of making the equation, can you just make any line with 2 dots? So we got the line. Okay. So we graphed the whole first piece. This piece is done. Let's go to the next piece. I want to focus on this one. So I'm going to, for 2 points, could I just technically plug in -1 and 1? Are those my 2 points? Can I just plug the edges of this one in? So if I put -1 into 4, isn't that 4? If I put 1 into 4, isn't that 4? But when I put -1 in, isn't that going to be a closed circle and an open circle? So I have a closed circle at -1 and an open circle at 1, and both output is 4. So at -1, I'm going to go up 1, 2, 3, 4, and it's a closed circle. And at +1, I'm going to put an open circle. And there's my graph. Because when I put in -1 to this, I got 4, closed. When I put in 1 to this, I got open 4. They're both a value of 4. And I connect the dots. So all you got to do is plug in the edges. And then connect the dots, because it's a straight line. All right, so that one is in blue. Last one, I'm going to do this one. Okay, let's plug in 2 to that function. That's kind of an easy function. F of 2 is going to be 2. You don't have to do anything, because we're plugging 2 into x, which is 2. So my coordinate's 2, 2, so can I go over 2, up 2? Is that a point? Now, is it open or closed? Look carefully at the sign. It's open. So let's make an open circle there. And then what we're going to do next is choose a value greater than 2 to plug in. What's a value greater than 2? Choose either 3, 4, or 5. It doesn't matter. Let's use 3. Okay. So when you plug in 3 to this, what do you get? 3. So when I plug in 3, f of 3 is going to be 3. Put that point. Do you have your graph? Done. All we did is we plugged in the edges as well as maybe another point. For these that have like these, do you understand you have to choose a point to the left? For this you have to choose another point to the right. And once you have that, you have 2 dots, you can make a line. For some of you, this might be an easier method for graphing it. Because my other way was, okay, 5 plus 2x. So I had to go up to 5, go up 2 over 1, which is down 2 over 1, make your line, and then you have to shade it. It got kind of confusing. This might be an easier approach. All right. Now, from there, your domain and range is still, you have to look at your graph. So for domain, and we're going to start making our domain and range in this notation. We're not going to worry about the other notation. We're going to do it in this brackets. We're not going to, when I say domain and range, I'm not going to use these notations right now. I'm going to focus on the brackety stuff. So as I span across this graph, as I look across this graph, do you understand there's a graph, but all of a sudden there's a gap. See the gap there? And you see there's another gap here? So when I talk about domain, there's these little gaps we got to watch out for. And another teacher mentioned this to me, and it kind of makes sense. Anybody play a little game where, think of there's a little guy here, kind of little guy, and he's running. Okay? As this little guy's running on this thing, he's running, would he fall right there? Anytime he has to jump, woo! Do you understand there's a break in your domain? Got that? He's running. Oops, he'd fall, right? So he has to jump. Boom. So you break in your domain. Anywhere this little guy runs, he's running across the screen. Anywhere he has to actually jump, there's a break in your domain. There are some situations where he'll just fall and he can keep going. Now, sometimes you have to jump up. That can be a little confusing though too. But basically, if you have to jump past a gap, if there is a gap somewhere that he'd fall into, that is a break in your domain. So if we wrote this out, our domain would be from negative infinity to, what would that be? Negative 2. And sorry, this should be parentheses. The reason they're parentheses is because open circle and infinity can never be closed. Then there's a gap here, so it starts up again. And this is a bracket from negative 1 to positive 1. And then it picks up again at 2 to infinity. So if you look at this, you running. Okay, jumped because he'd fall in the pit. Keep going. Okay, he had to jump again. And watch out for open and closed circles. So that would be your domain. Your range is kind of like the same thing, but you have to go up. It's like you're taking an elevator. Oh, I got to get out of my elevator, jump, and get another elevator. So as we go up here, watch this. As we go up the elevator, there's values. Okay, the building exists. All of a sudden, the building somehow doesn't exist. So you somehow have to jump that. And then you keep going. So for my range, my values are going to be from negative infinity to that value, which is 1. And these should be parentheses. Sorry. And from there, I go from 2 up forever. So then I go from 2 to infinity. Again, you're going up. Oh, there's a gap. Okay, jump back on. Okay, now I'm good. Go from negative infinity to 1 and then 2 to infinity. And again, sorry about I shouldn't have put those brackets until I knew for sure if they're closed or not. And lastly, if I want f of negative 3, could you look at your graph? Can I just look at my graph, negative 3 here, and go down? It looks about negative 1. But I need you to make sure you can do that without doing that. That's not always the best method. If we're going to find f of negative 3, look at all the intervals. Which interval is negative 3 in? Is it less than negative 2? Is it between negative 1 and 1? Or is it greater than 2? Where is negative 3? It's the first one, right? So what that's telling me is I need to take that first equation and plug in my negative 3 to it. And there's my answer. You could look at the graph, but a lot of times when you get these kind of problems, it might not even be on the graph. And so you have to figure out which equation you're dealing with to plug it into. Again, you could just look. Hopefully this helps.